How's everyone doing? Sure. Great. All right. Okay, so I'm Ron Chan, co-founder of Inference Labs, also operator of Subnet 2. I've actually been a serial entrepreneur for well over 2 decades now, had multiple exits, built data centers, as well as worked on national defense projects. One is NORAD, that's a North American Aerospace Defense Program. Someone's talking about nuclear bunkers. I was part of a major infrastructure program there. It's a bunker underneath the Canadian Granite Shield. As well as that, had a exit in civil aviation, and after exiting that, we launched Inference Labs. So, Ragme, yes, obviously, there's a lot of noise, and it is just noise. But quite honestly, we're all gonna make it. We're working in a space that, quite honestly, is just absolutely exciting. It is going to full stop make societal changes. So regardless of like the micro noises and stuff like that, we're in the right place. When we're kind of going through even like the micro things, like with BitTensor, when it comes down to DTAO to tau flow, how value extractors, weight copying, it's just noise to us. I think it will, founders need to continue to build, and we're going to make it. And the other reasoning behind it is the community. Honestly, we've looked at other ecosystems. Honestly, right now, BitTensor probably has the most amount of talent that I can find of any ecosystem and chain. So thank you. It's the community here, Rizzo, DNA, everybody for putting this on. It's absolutely incredible. All right. So I don't need to sell everybody on AI and just like the impact. It really is going to change, and it's being embedded, whether we like it or not, into every single surface of technology. Whether you like that SaaS product saying, "Hey, try this AI," or not, it is here. What's interesting, so besides me kind of like saying there's potential opportunity here, I think fundamentally how business is going to operate, it is going to change. I've been going not only to Web3 conferences, Super AI, Google Next, as well as that. Google invited us to the ZK Summit. Everything that I can tell is the way business has been conducted is fundamentally changing. And what I mean by that is previously software, you'd go and acquire a license. It'd be a company, they would buy some software, they'd install it on premise, and they'd pay for X number of seats. Then 20 years later, you fast forward to that and you start having these SaaS products, right? Somebody would come up with an application, and then rather than giving that application away, companies, people would provide data and supply, that exchange of value. And what's changing fundamentally with this agentic economy is that that the pendulum is swinging back the other way. What I'm seeing is that enterprise is now asking these SaaS companies, "Hey, if you want to sell your software, you're going to have to be able to launch it on our own private cloud," because they recognize that data is extremely valuable here. So with this actual change, what's going to happen is I see these silos that have been created by all these SaaS and cloud providers to basically dissolve. And the reason why is if you were a startup in the past 20 years, you're pitching some VC, the question is, what's your moat? And it's usually some sort of data lock-in, when you're actually trying to develop a moat and make it difficult for a customer to switch. And essentially that is your moat besides the network effects. In an agentic economy, that's completely changing because now AI agents are just giving goals and tasks. So, if we kind of have a rudimentary example of like Spotify playlists, I've never switched because all my playlists are there. It's super easy, even though I could. But if you had an AI agent, you could actually do that switch. So it's no problem. So when we kind of look at that lens and say, all right, there is going to be a ton of interoperability, right? These agents are essentially going to need to interoperate. Nobody trusts each other. It's like, yes, there's agent to agent protocols with GCP, but that's only if you're within GCP environment. So essentially, our main thesis here is we need some sort of auditability. And how we accomplish that is by providing some sort of autonomic forensics, whether it's an AI agent or humanoid robot. Anything that has some sort of autonomy needs some sort of proof of its existence. So when you kind of look at it, the past 20 years when we use technology, um, we've relied on biometrics. Like humans leave a trace. If in a physical aspect, we leave a trace of DNA. But if we touch technology, we're using some sort of biometrics or fingerprints, or we're using like Face ID. So when you have some sort of biometric like that and having the ability to kind of have some sort of traces, um, AI agents, humanoid robots, none of that actually has that similar equal until now. So essentially, what we do is we create a fingerprint of these AI models. So essentially, we take an AI model, and this is super high level, and the actual technology is ZKML, zero knowledge machine learning. And when you take that model, you can kind of run it through as this open standard. It's called Onyx. It's Open Neural Network Exchange. It was developed by most of the major big tech companies to allow somebody to go from TensorFlow, PyTorch, or run it on mobile. What we do is run it through this exchange format, which breaks it down to base math. And when it's broken down to base math, what we can do is apply other technologies to it. And in our case, we apply cryptography. And by doing so, we essentially create a fingerprint and a map of that particular AI model. And essentially, any output or any prediction that comes out of it can have a cryptographic proof that is published publicly. There's two advantages of this. One is that it doesn't actually require a vendor lock-in. So it doesn't have to be AWS. It can be completely agnostic. You can publish it anywhere. It doesn't have to be Web3. It could be just on the internet. And because it is protected by zero-knowledge cryptography, there is a veil of privacy. So the underlying weights and biases of the model is still actually obfuscated. So essentially, when we kind of take that lens, we kind of look at, okay, well, how does this work? And it's an abstract idea. So I like to use like real world examples. This is me, Chicago O'Hare, actually last week. So I've been grinding hard. Slapped this deck together last night. So ORD is actually number one in aircraft movement in the entire world. So obviously they are pushing for safety, efficiency. Anyone who's flown out of Chicago, it's an absolute nightmare. And what we're actually doing there is related to their winter operations. I'm Canadian, so we like snow. We understand winter. But just follow me for a moment. We have a lot of stakeholders at this particular airport, right? At a federal level, you have FAA. At the state level, that runs the entire airport. That's CATCO. That's city level. And then you have the individual stakeholders like the airlines, American, United. Those are the anchor airlines there, as well as some smaller ones. And in terms of the ground support, whole bunch of vendors there. They're providing labor. And you can imagine all these different stakeholders. Everyone is pushing what? Some sort of automation, some sort of AI. And what ends up happening, and this is real world example, is you have all these autonomous systems that are working together, but even without autonomy, not sure what happened with the video there, but you have all this autonomy, and the problem is it's a heterogeneous environment. So everybody has their own motives, right? They've signed some sort of SLA. FAA has their own kind of criteria on what success is. And what ends up happening is in those environments, you have different operators. And, even take autonomy out of it. When people are worried about job security, it's always like, okay, was it my fault? It was this vendor's fault, or this vendor did this at this time. and you add autonomy into the mix automatically. As soon as something happens at a particular airport, they want to blame the machines. And in this particular use case, and I'm not sure why the video is not coming up, but in this particular instance, it's a computer vision system that helps guide aircraft. So it uses visual guidance and it makes predictions based on aircraft movement. When it gets to a specific point, it tells like the flight deck to stop. Now, everybody's being measured through digital transformation. And in that particular environment, what ended up happening was that you would have, the service providers or the people providing labor, let's say they were slow, they're like team B, and then there's like an audit. Why did you miss that SLA? They'd be like, oh, it's the detection system, it's the AI system. And previously in that particular environment, it happened so much. The feedback would be like, oh, okay, well, here's the logs. And people would be like, well, logs can be tampered, like your model is running behind your firewall. It's just a text file. How do we know that that's when that prediction happened? It got so bad that they actually had to bring in a third-party auditor called NextGen to actually perform an audit that had absolutely no stake in the game to actually prove whether or not the automation was happening correctly. So essentially what we're doing there is this environment, and we are actually, we've circuitized the computer vision model and been able to actually produce a cryptographic fingerprint. Right. Okay. So that's kind of like an enterprise real world use case. We're pushing hard on that. I think it's super important because crypto Web3 goes through a whole bunch of cycles, ups and downs. I don't have a crystal ball, but I think it's important that projects are out there trying to find PMF outside of just interoperability within other Web3 ecosystems, as much as I love it. So let's touch on Web3 and how that's going to work. So it's not related to just BitTensor, although it comes up a lot in BitTensor, but any sort of like incentivized open participation network, it will always attract some sort of cheating or malicious actor, right? I don't need to kind of explain that. We've seen like weight copying with BitTensor. It isn't just BitTensor. You see it all over the place. And anybody's going to try to take advantage of that type of situation. So with, right, somehow we missed a slide. So some milestones on BitTensor Subnet 2. We launched April 2024. We just actually crossed 300 million proofs. So the miner's been fantastic there. Because really when we were kind of coming up with this thesis on this second order problem, it was the fact that, where are you going to get this infrastructure? And BitTensor actually was very quick for us to kind of spin up this infrastructure. The miners have been incredible. In terms of tau emitted, I mean, I didn't check the prices, but, over $9 million have been issued to validators, miners, just from Subnet 2 alone. We've created the largest decentralized ZKML proving cluster, and we kind of look at it as like a PvP battleground. Essentially, there's a whole bunch of different proving systems out there for cryptography, but not all of them are going to be as efficient for different mathematical operations within AI models. A lot of the proving system libraries that are out there have been built for production use for, say, L2s. And it's been amazing seeing the actual growth in L2 and the adoption of zero-knowledge cryptography. We're almost at like atomic operations, but block sizes are only kilobytes in size. AI models, they are megabytes to gigabytes in size, or even terabytes. So having Subnet 2 be this live benchmark and battleground has been very beneficial. And I'll get to that with some unique technology that we're just about to launch. Okay, so adoption within this ecosystem of BitTensor. So is anybody familiar with PTN? Great. Okay, so for those who are not, I'll just try to keep it super simple. But essentially, it's a proprietary trading subnet, and it's open participation. It used to be no barrier of entry, but they kind of like elevated it, so you actually have to you have to put up some collateral. But basically, anybody who thinks that they're able to make trades and do them well are able to basically become a miner there and provide signals, because who wouldn't want that to, predict how, the price of Bitcoin is going to go. So you can see the value there, and they sell those signals to third parties. So it's, a fantastic idea, and it's actually, as a subnet, it's done quite well. And essentially they compete based on this particular risk-adjusted return KPI. Now, what's the problem? So essentially what would happen, and kind of going back to what I'm saying about the cheating, there would be miners per se that would say, okay, here's like all of our signals and our trades. But the problem with that is, and miners, even within the tensor, it's not just that subnet, they treat a lot of their development work as IP. It is confidential, because that really is their competing and their edge against other miners. So in that particular environment, they don't necessarily want to reveal like all of their IP and what they do. As well as that, the problem is there would be miners that would cheat. So for instance, they would not reveal bad trades and only submit like good trades. And what would end up happening is it'd be difficult for validators to kind of base their decisions on that. So essentially, Subnet 2 is producing proof of portfolio. GitHub's live, it's public, everybody can kind of see it. We're going through some PRs, but it should go to mainnet very soon. And essentially, it does create a cryptographic proof where anybody, it doesn't even have to be validators and miners, anybody can actually run that check to actually cryptographically guarantee that portfolio, that miner actually ran that computation and made that particular trade. The other advantage there is that it also veils that particular portfolio with some privacy. So you don't actually necessarily have to reveal all of their IP at the same time, providing that assurance, which is exactly the use case of what we're building. So going forward, what's our like achievements or advancements? We basically, and I think one of the biggest criticisms for ZKML is primarily the cost of computation and the speed. Even with some of our advancements, we're still very early. But people kind of talk about AI inference in like number of tokens per second. We're still seconds per token. But there are some interesting advancements that we've made recently. Went from research paper in August to a live repo and in production as of last month. That is Disperse. And essentially what we do, which is interesting beyond just speeding up ZK proofs, is that it allows for us to not only provide that kind of slicing technology. Basically, we kind of break up an AI model so that we can kind of do targeted verification. So previously, it was like, one-shot deal. You'd have to be able to cryptographically create a circuit for the entire model, or else you wouldn't be able to do a proof. Now it allows us to kind of do that. So we're able to circuitize much, much larger models. As well as that, Just Prove, that is our own ZK proving toolkit that basically makes it super easy for developers to take a model, convert that to Onyx, and then create zero-knowledge proofs from. So I mentioned Disperse. I kind of call it in the crypto community as unruggable AI. Typically, in the past, when people talk about decentralized AI, it is, how do we incentivize a bunch of people to kind of take some compute and, whether it's GCP or it's their own hardware or AWS, and then just designate a model to run on that particular piece of hardware. That to me is a great first step, but it doesn't change the fact that one, that model could go away, that compute could just disappear based on incentives, and two, we're not guaranteed that model is actually running on that particular piece of hardware. We talk about open router, we talk about a lot of decentralized computation, and there is some compute subnets as well, and they've run into the similar problem. It's like, okay, I'm promising this hardware, but I actually deliver this other hardware that's cheaper. Or it's like, okay, I'm promising that I'm going to run this other model that is more computationally expensive, but really I'm just going to supply the inference to something cheaper. Disperse kind of eliminates that. So that's why I'm kind of saying it's a bit of a unruggable AI, because we can slice up that model and distribute it across multiple nodes, and then that's going to give you more availability as well as redundancy. Uh, Another video that didn't work. But you know what? That's okay. What I can do is I think my final slide here has a QR code, essentially tons of resources. Please take a look at our website. Um, we are just beyond theoretical now, so a lot of GitHub repos are all public. You can participate in the Discord in terms of BitTensor. We subnet to there. We also have our own socials and everything like that. So yeah, thanks. If anybody has any questions.
Well, and what kind of traction have you got in solving weight copy in BitTensor, and what kind of persistence or challenges are you seeing?
In my eyes as a founder, we've delivered everything we can. We've submitted like the BIT. We've worked with Church of Brow. It's like the software is available. I guess, besides words, I think the best truth is action. And we just haven't had the support. It seems like everybody is, saying weight copying is a problem, but I don't know if it's a problem that people want to fix. So it's there. It's ready to go. We've done everything we can. The reason why I'm saying that it needs that last mile is really hyperparameters. And it isn't like we're trying to release like an entirely new solution. It's based off commit reveal. And primarily we just need those hyperparameters. We're not shoving it down everyone's throats. Individual subnets can choose to eliminate weight copying or not. And essentially it's the same thing as I described here. It is proof of computation. Did you do that computation or not? Rather than obfuscating and encrypting the weights, it's just running a calculation and either proof passes or it doesn't.
All right. Well, from a talk earlier today, I'm curious about how your incentives mechanism works. How you incentivize different model sizes and maybe encourage minor innovation, stuff like that.
Yeah, great question. Historically, it has been incentivizing for the quickest proof times. We are switching that out. It was based off of a lot of synthetics. We're in a research phase. We are imminently going to launch Disperse onto Subnet 2, which is going to open up a whole bunch of other opportunities and a brand new incentive design.
What are some of your roadblocks that you're hitting right now, and where's your choke points at?
Yeah, another great question. It's been a huge relief because my biggest one was we had theory and research that this could be done, and we've been working for like a whole year trying to get this accomplished. Now that we actually have these first, that computer vision model and that the airplay prediction, it was literally last week we were able to kind of fully run that model and do a proof of concept so I could do a demonstration. So that in hindsight, that was our biggest problem is I'm out there doing BD and I'm an enterprise guy, and without a product in hand, it was very difficult to sell a solution. So that was great. I think the other major hurdle that we have to overcome, and it kind of goes back to my second slide of Wagney, we're solving a second order problem. And when we're kind of looking at AI in general, a lot of criticism is that it's not making anybody money, right? It's like, where's that value occurring? And us kind of solving some problems is a second order problem. Now, with that being said, I think we still are early. And when I was like, okay, everyone chill out a little bit with tau flow and stuff like that and value extraction, you look at OpenAI, I think it was just disclosed that they've lost something like 12 billion in quarter. So these tiny little subnets that are genuinely trying to build something, you're going to have to be a little bit patient on some of that. I kind of put ourselves in that category. Any other questions? They're good ones, though.
That was awesome, bro. Thank you, guys.
Yeah. Okay. Thanks, everyone.